Hey everybody, welcome to our webinar today, Home Air Quality Monitors. I'm Joe Martinez with Electrify Now here with Wesley Allen, who's been assisting us with Clean Air Week all week and all the great preparation and webinars that we've had in store. We also have Brian Stewart with Electrify Now. He'll be our panelist that we'll introduce more in depth in just a second. Great to have you with us. So Wesley, okay, we are on day 3 of Clean Air Week 2025. Tell us a little bit about this week. What have we been talking about, learning about, and what's to come?
Thanks, Joe. Yes, Clean Air Week has been so much fun so far. We've had a few webinars already, and really the purpose of Clean Air Week is to highlight the dangers of using natural gas, particularly indoors. There's a lot of people highlighting the outdoor dangers of pollution, and so we really wanted to drill down on the health hazards of indoor natural gas use. So another purpose of Clean Air Week is to really highlight the practical resources that consumers can use to improve indoor air quality. And we also wanted to just bring together advocates from all over the nation who are working on these issues and advancing healthy air quality standards in various states and jurisdictions. So we've had, like I said, we've had a few events already. They were really wonderful. We had an event on the dangers of natural gas in the home. Yesterday, we had a presentation on home air filtration that was really informative. And today, of course, we're focusing on home air quality monitors. We also want to invite you all to the remaining webinars. So tomorrow we have one on Electrify 101. So this is really for folks who are in the midst of their electrification journey or wanting to get started. And we'll provide information on kind of where's your biggest bang for your buck in terms of improving indoor air quality. Also, if you have concerns about the climate, to address some of those. So it's going to be a really great webinar from Rewiring America and the Building Decarbonization Coalition. Then on Friday, we have a panel of experts from all over the country who will be discussing decarbonization efforts, both at the local level, the state level, and also where we are at the national level to really clean up our air. Lastly, if you're in Portland, if you're here in Portland, Oregon, locally, there's an electrification fair that's taking place on Saturday. So we really welcome you to join us there as well. And I forgot to mention, we'll also put the upcoming webinars in the chat in just a second for those who want to register and join. Also wanted to mention on our website, and we put the URL there, there's some really great shareable graphics and resources, including a fact sheet, which you see on the right, about the different pollutants in natural gas and some of those health effects, and then some images that might make you think. Feel free to take those, to share them, to use them as you wish. This is a fun one. So we've also created for Clean Air Week, and we'll probably continue this for a couple weeks afterwards, a natural gas quit line. So this we're taking, from the public health campaign against smoking, taking some of those strategies to really promote this quit line that you can call 1-877-QUIT-GAS and leave a message, and we'll have electrification experts respond via email, or we can give you a call back too, if that would be better, to just help guide you on your journey and give you some resources to help problem solve. Back to you, Joe.
Yeah, especially water heaters. I love water heaters, and if y'all have any questions on heat pump water heaters, happy to chat all day about those. All right, well, thanks so much, Wesley. Really excited about this entire week. And today's webinar in particular, we're going to be talking about home air quality monitors. Now, this webinar is really paired with our home air filtration webinar from yesterday. We'll put a link for the recording on that. But we're going to talk about how and why to monitor air and why it's crucial to the health of your home. We're going to look at some of the indoor pollutants and how they can affect our health. We'll provide some practical guidance on which air quality monitors are out there and what are their benefits and drawbacks with some recommendations, and then talk about where do we place these air quality monitors as well. And we're, of course, so thrilled that Brian Stewart, the co-founder of Electrify Now, is here to talk to us about this. Brian walked us through an incredible webinar yesterday on home air filtration. But Brian he co-founded Electrify Now to help energy consumers, to help consumers save energies and learn about the benefits of electrification. He's got 40 years of experience in product design, engineering, manufacturing, and sustainability, and he held many leadership roles at Nike, including Vice President of Sustainable Innovation. So Brian, maybe as you're kicking up and loading your slides, tell folks a little bit about why you got interested in air quality and how to detect it and how to clean up our air.
Yeah, so thanks, Joe and Wesley. Nice to be here today. Let me just tee this up. So yeah, I first kind of got interested in this topic about air quality and filtration. I'm super passionate on this subject, and I first kind of got introduced to it when it was about 12 years ago or so. I was sort of dreaming. I was thinking about planning ahead to when I would retire and dreaming about building a wood shop, and because I've always worked with wood and that sort of stuff dabbled in my spare time, and so I was thinking about building a really nice wood shop. And so I started thinking about keeping it clean and air filtration and dust management, all that kind of stuff. And I stumbled across this information from this guy because at the time, it's shocking how different things are now than they were then. All these monitors we're going to be talking about today didn't exist at the time. It was really hard to find good information about air quality inside. And air filtration was kind of not a thing also. I mean, the state of the art for wood shops at the time, and anyone who's out there who's a woodworker will know that all those, the kinds of dust management systems, they call them, they're really meant to collect the wood chips. And so they would collect them into a canvas bag and just blow all the fine particulates out through this loosely woven canvas bag that nicely collected the chips, but blew all the dust back into your shop. And so this guy who I stumbled across was a university professor in mechanical engineering, a woodworker, and he had some real health issues, lung-related health issues that he realized were coming from the dust the fine particulates he was breathing through his woodworking. So anyway, he had all these recommendations about how you could build your own HEPA filter to filter out stuff, because the stuff that you could buy commercially was basically useless. And so I kind of went down that rabbit hole, built a lot of stuff myself for my own shop, and learned a lot about this, both the health issues of particularly fine particulates and also the mitigation strategies, which is one of the things we're going to be talking about today. So that's kind of how I got started on this. And then as I got into electrification, I realized that a lot of these same issues are related to fossil fuels combustion, and basically this notion of keeping our indoor air quality clean is just so important. So I'm excited to be here to talk about this with you all today. Yeah. So, all right. I just kind of feel compelled because we're Electrify Now to just remind all of our audience out there that, today we're talking about cleaner indoor air, one of the major benefits of electrification, but there's other ones, that we won't be talking about today, about lower energy bills, increased comfort, safety, and convenience, lower air pollution, that we will be talking about that indirectly today. And then of course, electrification, there's nothing better you can do in your home to lower your carbon emissions than electrify your home. So I just like to remind people of that, even though today we're really keying in on clean indoor air. So why is it that home air quality monitors are so important? Again, I mentioned this yesterday during our filtration webinar, but this is a study from American Lung Association that says that nearly half the US population lives in places with unhealthy levels of air pollution. And I think we're pretty familiar with where air pollution comes from. More and more wildfires are a problem. But the main source has historically been urban air pollution from all the fossil fuels combustion that happens with automobiles. But also, a lot of people are not aware that our homes that burn natural gas, our buildings that burn natural gas for heating and water heating, are a major source of urban air pollution, and one of the reasons why we need to focus on eliminating natural gas combustion. And then inside our homes, cooking is one of the shocking sources of indoor air pollution. Again, stuff that typically you can't see. You know, the smoke, of course, you can see that if you burn something, but there's a lot of stuff that enters our air from cooking, particularly with natural gas, that is really bad for our health. So these are the main sources. And you know, if you, on the outdoor standpoint, you know, now we have really good information about local air quality. This is a snapshot of the map of the US. I took this the other day. And all this relates to the EPA's kind of metrics that they put together about criteria pollutants, and, you know, a rating system from good, green to really hazardous and unhealthy. But one of the things I like to point out to people is that, you know, you can sort of say, well, yellow, moderate, it's not that bad, you know, yeah, you know, I'm not too worried about that. And it's true, if you have to go outside, I wouldn't let a yellow day maybe keep you from doing that, although you might not want to run or something if it's in close to 100. But it's important to realize that the exposure risks to these pollutants we're talking about is cumulative, a lot of it. So, you know, a lot of days outside, living your life outside in a yellow situation is, it's not good. You know, it's obviously, that's better than living outside in a red situation. But, you know, the point is, the more you can avoid exposing yourself and young children in particular to these pollutants, better, because, you know, this is going to stack up in your body over your lifetime, because you are the filter in this case if you're outside and breathing this stuff. Okay, so the other thing, the reason why this is so important is because indoor air quality is not always better than outdoors, and sometimes it can be worse. So that's why these monitors are so important, because, you know, if you have an open window or door, that's going to let pollution in, of course. But as we mentioned, cooking can make indoor air worse than outside. And then, of course, some devices produce carbon monoxide and other pollutants that can be lethal if you are exposed to them in high quantities. Okay, so as we mentioned yesterday, one of the good news is that running air filters and using air purifiers is really effective and affordable for a lot of the pollutants we'll be talking about. Not all of them, but a lot of them. We'll get into that. And so we did this webinar yesterday. Check that out if you're interested in more information about this, because there's some really good things that everyone should just know about how to make sure you're maximizing the effectiveness of air filtration in your home. But okay, so this is kind of the central question. How do we know if the air quality is safe? And you know, I have this picture of blue sky here on purpose, because of course, if you're near a wildfire and, you know, you can barely see the sun and you can't see across the street because of the smoke, of course, you know, the air quality is bad. But you'd be surprised how many days when the sky is blue and yet the air quality is bad. And that's because a lot of these pollutants we're talking about are invisible. You can't see them because they're either so small or they're gaseous, which we'll get into. So the primary methods we have for knowing where their air quality is safe are detectors. You know, we've grown up with these. We'll talk more about them. Those are things that a lot of times building codes require. There's more and more really good information about outdoor air quality maps. I showed that one from Purple Air, but, you know, this has exploded in the last 10 years in terms of the number of stations that are reporting information. And so basically almost anywhere in the world, you can get good local outdoor air quality information now. But the new thing really is these indoor air quality monitors, which you basically have to have if you really want to know what's going on inside your home. And that's true whether it's apartment, home, you know, office, whatever. Inside a building, you need an air quality monitor to know what's going on with your air inside. All right, I want to talk a little bit about each of these things. Detectors, you know, as I said, we've grown up with these things. These are basically alarms that are going to start to create a really nasty noise if they detect something that's unhealthy or lethal. And of course, smoke and fire detectors are the ones that all of us are familiar with. And, you know, these are a pain in the butt because the batteries run out and you have to replace them, et cetera. There are some ones now that have really long lithium ion batteries. They'll go 10 years without having to replace them. I highly recommend those. But you need to have those in your home. And of course, carbon monoxide detectors are important as well. This is really important if you've got a detached garage or attached garage, for example, because carbon monoxide can come from your automobile. It also comes from burning anything in your home, whether you've got a fireplace or gas appliances. And then the thing that most people are unfamiliar with, but I'm a big fan of, are if you've got a natural gas combustion going on in your home, furnace, water heater, gas stove, gas fireplace, you really ought to have one of these natural gas alarms that you place in the vicinity of those devices that are burning natural gas. And they're going to let you know if you've got a natural gas leak, which can help you avoid an explosion. You know, if all you have to do is Google it, you'll be shocked at how frequent gas explosions occur in homes across the country. These things are relatively affordable. I'd say anyone who lives in a home with a natural gas appliance should have one of these. And these are not required by code, but I think they're really good for just for safety. Okay, outdoor air quality. Again, we've mentioned this already, but it's good to know, you know, Purple Air has been around for a long time. They have these small monitors that it's kind of a crowdsourced thing. We have one on our home. You buy this little kit, attach it to your home. You're part of the community. This is our sensor here. This is Portland. This is from yesterday, by the way. So, I mean, the air quality here was bad. It doesn't look bad. If you look outside the window, it doesn't look that bad, but it's not good. And since I've been doing this, we got ours about, I don't know, 10 or 12 years ago. The number of stations that are reporting in Portland has probably quadrupled. So, you know, you can get information down to the neighborhood now that, you know, before was more like this. This is the US EPA site that has fewer stations. They're more kind of sophisticated sensors that measure ozone as well as PM 2.5. Purple Air really is just 2.5, but also some of these, you know, interesting weather information. But Air Now, which is the EPA site from the government, has, so again, this is our Portland area. You can see there's only 5 or 6 sensors here in our area that are measuring ozone and PM 2.5. And then there's other ones like IQ Air, which is another global one, which has pretty good representation. Again, this is the Portland area. So you can just kind of compare the number of sensors that are available in each place. So that's great. I mean, this wasn't a thing a few years ago. So it's really good that we have this. But now let's talk about indoors, because this is, you know, really the meat and potatoes of our conversation today. The good news is that there are all these new devices that are relatively cheap that provide real-time sensing and reporting on a host of indoor air pollutants. And it can be confusing in terms of all the things they report and stuff, which is why we're going to go into this. There's a range of prices and functions. They start at, you know, maybe just a little over $100 and go up to several hundred. And some of them have a lot of functions. Some of them are really simple. We'll talk about that. The typical measurements include these that are common: AQI number. That's that air quality index reference from the EPA that we talked about that has the red, yellow, orange, green, yellow, orange, red, maroon kind of scale of severity of pollution. PM 2.5, that's a number that gives you the, you know, the parts per cubic meter. Temperature and humidity, of course. Then some of them will also give you information about local air quality outside and outdoor temperature, which can be useful. And then there's some of the newer ones have all these other measures: carbon monoxide, carbon dioxide, nitrogen dioxide, VOCs, volatile organic compounds, ozone, and even some of them have radon. Okay, so this can be confusing if you ask me personally, and I'll explain why, but I think these are the most important. These first here that are about AQI and PM 2.5 and outdoor as well as indoor. I think this is really useful. It's actionable. We know these measurements are highly accurate because this kind of sensing technology has been around for decades, been perfected. It's cheap. It's really easy to incorporate in sensors, in relatively small sensors. And there's a lot of redundancy in some of these systems, you know, so you know you're getting pretty good data with this stuff. These I would consider to be interesting. For the most part, less actionable. I'll explain why. And the accuracy is harder for me to vouch for. I don't have a reason to doubt the accuracy necessarily, but I have to say I'm skeptical because these are relatively new. Some of these very small devices have 10 sensors in them. You know, I don't know. There's just a room for skepticism about how well They really are tracking these gases that are involved here on the lower side. But I don't necessarily mean to dismiss them. I just think it's important to know why these things are potentially interesting to monitor and what you should know about them. So let's dive into that a little bit. So first of all, let's know the health impacts from these things. So PM 2.5 and PM 10, those are two that are pretty commonly reported. This is particle size information. And the symptoms from these things they overlap a lot, but generally speaking, it's the same problem because these are small particles, but the smaller they get, like PM 2.5, the worse the effects are. And also the harder it is for your body to get rid of them. Like PM 2.5, basically once it's in your body, it's not going to get out. It's going to get into your bloodstream, et cetera, bury itself in your lungs. It's really hard to deal with. PM 10, which is often associated with things like allergies and mold and stuff like that, is a little bit easier for your body to deal with, but it's also nasty. And then these things here, carbon dioxide, carbon monoxide, nitrogen dioxide, volatile organic compounds, and ozone, range in severity of symptoms from, carbon dioxide is mostly, you're going to feel woozy, drowsy, might get a headache. Carbon monoxide, same, but in high enough concentrations, it can be lethal, which is one of the reasons why we have carbon monoxide detectors in our homes. These other things, nitrogen dioxide, VOCs, et cetera, on the mild side, they're going to be irritants, but on the long exposure to them can lead to infections, cardiovascular disease, and even cancer. So these are nasty things. And then radon, which is one of the things that is not often reported with these sensors, but some of them do have them. This is serious stuff. This is a gas that can cause lung cancer. Okay, so it's also important to realize that air filtration can easily deal with PM 2.5 and PM 10. There's really good air filters now. I mentioned, my experience with the wood shop, it was hard to find a HEPA filter. Now you can find a device for under $100 that's got a HEPA filter in it. And they're exceptionally good at eliminating these fine particles. So air filtration is a really good way to solve this. These ones below, air filtration is not going to do anything for you because these are gases. As I mentioned in the air filtration webinar yesterday, there are some filters like carbon filters, which can absorb these gases, but you need pounds and pounds of carbon to absorb the kinds of gases that can be created by a gas stove, for example, and they're really expensive. So in general, it's cheaper to replace your stove than to have one of these kind of carbon-based filters. Okay, so that's one thing. I don't want to poo-poo these things down below because these are serious health concerns, but we don't really have good mitigation strategies for them, as you'll see here. So let's talk about sources and mitigation strategies again. So PM 2.5 and PM 10, these are the culprits. It's pollen, mold, dust, pet dander, smoke, wildfires, or even, like a campfire, or if you have a wood burning stove or a fire pit, you're producing this stuff, soot. And mitigation strategies, as I mentioned, are really good because of air filtration, air purifiers. CO2, carbon monoxide, NO2, these other things, this all comes almost 100%, maybe let's say 85% of the source of these things is from fossil fuels combustion. So outside, that means cars, industrial sources, natural gas heating for our homes and buildings. That's where this stuff comes from. So the sources of these things that we're exposed to from the outside are carbon, related to carbon emissions and combustion of fossil fuels. Inside, it's also combustion. It's our gas stoves, wood or gas fireplace, and maybe, leaking from our furnaces and water heaters, but the main sources are going to be gas stoves and fireplaces. So what are the mitigation strategies here? Well, if it's coming from the outside, about the only thing you can do is close your windows and hope that, eventually more and more of your neighbors stop burning natural gas in their homes, and more of our community starts driving electric cars, et cetera, to reduce the air pollution in our cities. So there's not much you can do about outdoor sources of this stuff because, again, there's not a filter that will keep your house clean. You can close your windows, which will help, but if it's in your home, it's not going to escape from a filter. And then the other thing we can do is eliminate indoor combustion. So as I mentioned, it's going to be cheaper for you to get a new induction stove than to get a carbon-based filter to filter your air if you've got a natural gas furnace, or sorry, natural gas stove. So that's just part of the deal. And radon, which again is nothing to be poo-poo about. I mean, some parts of the country, this is a serious issue. It comes from radioactive decay of uranium in rocks in our soil. So if your house is built on some of this material, you can get that gas leaking into your home. We had this situation with our home. The solution is that you basically drill a hole in your foundation and then ventilate those gases to the outside. It's not super expensive to do this. You're talking thousands of dollars, maybe low thousands of dollars. There's really good strategies for doing it. But again, an air filter, an air purifier isn't going to deal with this. So this is kind of the combination of these things is why I consider, you know, these top things here to be super useful, actionable. They're highly accurate. These bottom things are important and they're interesting, but maybe not as actionable. So I'd say if you've got a gas stove and you're not convinced that your house is being polluted by it, you should definitely buy one of these monitors that has an NO2 sensor in it, because it will tell you how bad this really dangerous pollutant is in your home. Or maybe someone you love, like your mother maybe, who's just loves to cook with natural gas and isn't convinced that she needs to get rid of it. Buy her one of these monitors that has an NO2 sensor in it, and she will see immediately, and PM 2.5, that as soon as she turns on her gas stove, NO2 and PM 2.5 are going to shoot up. So that's a good use of these monitors. I say, if you're already convinced you don't need a gas stove, then I'm not sure you really need these other metrics in your home. But you know, that's for you to decide, not me. All right, so let's talk about some of the good monitors that are out there. This is information that comes from Consumer Reports and other reviews. And so what I'm showing you here are the ones that kind of typically pop up in those reviews. All right, I'm going to start with my favorite one. And we've got several of these, so I've got a lot of experience with them. But IQ Air has this monitor called Air Visual Pro. Unfortunately, it's one of the more expensive ones, $329. But here's why I like it. First of all, it gives you the AQI number. So so you can easily like make a relative kind of assessment of the indoor air quality to outdoor, because we're familiar with these outdoor air monitors now that have this rating and a number. So you can see on this display, I really like that it's giving you the air quality number inside, and also if you want, you can look at the fine print and see what the PM 2.5 is. But I mean, do you need that if you know that your air quality is 12 on this scale? I mean, I don't know that you need to know what the parts per million is. It also gives you the outdoor information at the same time. So in a quick glance, you have an idea about what's going on inside and outside your home. Gives you some good information about, you know, weather information, all that kind of stuff. Gives you CO2 information. You know, if you don't have a gas stove in your home, that means you're standing too close to your monitor, and the CO2 from your breath is causing the sensor to go up, because there isn't going to be any other source of CO2. So I hardly ever use that one. So love that one. Another one that people tend to like is this really nice, cheap one. It's small, which a lot of people like. Some people, it can run on batteries, so you can even take it with you if you travel, maybe have it in your hotel room. It has some of these same things. It's got, it doesn't have the AQI number, but it's got AQI color coding. So you can see this light here, because the parts per million is low, it's giving you a green light, which equates to the AQI ratings. The thing I don't like about it is you have to kind of like touch the top of it to toggle through these ratings. So if you want to see anything else, you got to toggle through it. So I just don't see people doing it, which is again why I like this thing where you just walk by it, it's in your kitchen, you're going to glance at it, and you know most of the things you need to know. Here, another highly rated one, which I really don't get, is called the Air Things. You might like this if you really want all this information. You got to toggle through it to get this stuff. It's telling you your PM 2.5 is, you're gonna have to like look at the manual to see what that number means. But because there's no qualitative information along with it, you got to wave your hand over it to get it to trigger and to take a reading. Otherwise, the numbers that are on there are from the last time it took the reading. So there's a lot of things that I think are just clunky about this, but I don't know, it gets pretty good reviews. This is another one, the temp top one M100. This is another one that has really good information. You know, I guess if you like a complicated dashboard, like a cockpit, you probably love this one because it's got all this data in it. It also has this nice feature of a weather forecast, which I think is pretty cool. So it's kind of like a weather station with more information about particulate matter, that sort of thing. So pretty good. I think it has a phone backup, a phone app that comes with it, which is nice. And then the most sophisticated one is this Yoo-hoo monitor, which I'm pretty impressed with. You know, they actually have had, this is the one that I've been able to find that has third-party laboratory testing to back up the accuracy of its measurements, but you can see it's a host of things that it measures. It doesn't have any, this is the thing, the sensor here in the back. The only way you can tell what's going on is to get your phone out and look at it. So to me, that's a downside. And again, you got to wade through this list of information, decide what it is that you're interested in, which again, I just find problematic in terms of just human behavior. So again, you're going to get to decide which one of these is right for you. I'm a big fan of this one, again, because like I said, take a look at this, glance your eye over it. Which one is telling you really good, actionable information in a nanosecond? It's this one. Okay. But again, like I said, you're the one who decides. Okay, this is another important thing to think about is where's the best location to put one of these air monitors. If you get them or several, you might even want a couple of them. Your kitchen is probably the most important place to put them for a lot of reasons. One, because cooking is your main source of indoor air pollution. And this is true whether you've got a gas stove or not, because even if you've got an induction stove like we do, and if you cook on high heat, you're going to create particulate matter inside. So you're going to know instantly whether you need to turn on your air filters or run the furnace or heat pump fan through your filters to clean the air. So kitchen is a good place. It's also a good place because you spend a lot of time in your kitchen. And you know, like I said, we have ours, we put it on top of our counter. Every time you go in there to get a cup of coffee or make food or whatever, you instantly get a good sense of what's going on both inside and outside. The other place to put one might be your bedroom because you spend a lot of time there as well. And I would say if you have children, I would absolutely put one in your children's bedroom because you want to know what's going on there. Children are more susceptible to all these pollutants than adults because of their developing lungs. The relative surface area of their lungs to their body is bigger. So there's developmental issues associated with a lot of these pollutants. So I would absolutely, if you know, when our kids were young, this wasn't available, but if I were a parent today, I would absolutely put one in my kids' bedrooms. Okay, so I would remind everyone about, you know, we did this webinar on home air filtration. If you're interested, we're going to have that on our YouTube station and you might just want to take a look at that. But yeah, so that's it. That's it from me.
All right. Well, great stuff, Brian. Yeah, when you were talking about mothers or mothers-in-laws who need that NO2 or some air monitor, that was ringing home for me. Yeah, people. I think a lot of folks don't.
Those things I think would be a great Christmas present for their family members. You know, to let them get a good idea about what's going on in their own homes. It's a great way to just convince people that they should take action.
Yeah, I think a lot of folks who are worried about other risks don't, you know, keep burning their gas stoves and don't think about all that pollution. So
no, it's surprising, isn't it? I mean, you know, there's people who are going to like be really careful about what they eat and, you know, things like that, but they're unaware of these other things that are just so important to their health.
Yeah, great. Well, we've got a lot of questions in there. I think maybe one area we can start is something that you were highlighting on, and maybe you could get in some more detail. Some of our listeners were talking about the questionability or the question on the accuracy of the NO2 and the VOC filters, just because there's just these are gases that that can give false alarms, or they're not present in high quantities, so it's hard to really detect them. Any other thoughts on that? You know, whether you're trying to really actually detect for NO2?
You know, I think there's reason to be kind of skeptical there. I wish I were more knowledgeable on this. Maybe there's someone who's really more in the science realm that could comment on this. But here's a little kind of anecdote on that. I mean, when you see reviews on these devices, there's almost no commentary on their accuracy. And I think the reason is because it takes some real sophisticated laboratory equipment to decide whether they're accurate or not. So that is part of the reason why I'm a little bit, I don't know, uncertain about how accurate they can be, because we just don't really have very good third-party verification of that. And my suspicion is that they're probably directionally correct, but maybe not that accurate. So again, I don't feel it's my place to sweep them under the bus or cause, undue suspicion, but I think it's a good question. Whereas with the particulate ones, again, these devices have just been out for so long. And, like I said, if you look at the outdoor ones like Purple Air and other monitors, you can actually cross-reference particulate measurements in your neighborhood, and they're generally speaking going to be pretty close. So I you know what I'm saying? So I just feel like there's just more redundancy and accuracy in that than there is maybe in the other ones, but I don't know. If anyone on this webinar has good information about that, maybe from a more science-based background, please share.
Thanks, Brian. And just a reminder to everyone, feel free to submit questions in the Q&A chat. We'll try to get to as many of them as we can. On that topic of accuracy, Brian, there were a couple questions in the Q&A about calibration and whether these devices need to be calibrated, and if so, like what that interval is typically. I suspect it differs device to device.
Yeah, I can't comment on that. I think that's something we probably have to look at the manuals. But I do remember that our panelist on Monday, Curtis Norgard, who's a physician who's quite knowledgeable about the effects of NO2 on children and in his patients, commented that there is some calibration that's required for some of these devices, but I'm not knowledgeable about that.
Yeah, we'll if we have any follow-up information, we'll send that out in our email. But yeah, great questions.
I would say maybe a good thing to do if you're thinking about one of these devices, what I would do is I'd go online and get the user manual for it before you buy it and see what it says about that. And also just look for whether there is any third-party validation of the testing accuracy of the device. Like I said, I found that for the Yoo-Hoo monitor. They had some very rigorous testing that was done on their device, but I didn't see that for other ones.
Okay, cool. Okay, so a couple things on the actual, like just natural gas leaks. You talked about that natural gas monitor, which was news to me. I didn't know about that type of monitor. Michael's asking if those measure natural gas leaks or just carbon monoxide, if you know. And then just on a follow-up to that, Rachel's wondering, what about like outdoor leaks? How do, if folks are thinking that there might be natural gas leak, is there any outdoors, is there any monitor that will measure that or detect that?
Yeah, so my understanding of that Novo Detect monitor is it's detecting unburned methane. So it's really a explosion risk detector. So it's not measuring combusted gases, the carbon monoxide detectors do that. I think that is a super interesting thing. Again, I haven't gone deep enough into it to know, like the validation of the accuracy, but I spent some time on their website looking at this and they look legit. And in fact, there's even been some places in the country that have, I think Michigan passed some building codes or came close to passing building codes that required those monitors in new construction. So I think there's a reason to be confident about the accuracy of those things as explosion risk detectors. So again, like if I had natural gas in my home, I would absolutely have one of those. On the question of outside, that's a little bit trickier because when you think about this, that gas leak detector in your furnace room, let's say you've got a utility room with a furnace in it, it's a closed space. So if you've got a gas leak in there, it's going to accumulate, and so the concentrations of it are going to get high enough where there's an explosion risk. So that's what that device is measuring. Is the concentration of the gas high enough in that confined space to create an explosion risk? Outside, there's no confined space. So the sensitivity of the sensor has to be way higher to be able to detect whether there's a concentration of gas that's an explosion risk in an unconfined space. So therefore, the cost of a sensor to detect gas leaks externally are way more expensive. I'd spent some time looking at this because, I was Joe and I were contemplating this idea of hiring some college students to run around Portland and measure, manhole covers where, all the little places where the gas utility lines go to see if there's leaks happening in our city. And this has been done in other cities like on back east where there's really old infrastructure, gas infrastructure that's very leaky. But those kind of community science activities, they ponied up and bought $3,000 monitors. So and that's kind of what you're looking at, several $1,000s for a monitor that's capable of measuring that effectively and accurately.
I just put a link to, we did a gas leaks webinar a year or two ago, and I found the recording and put a link in the chat for that went into more depth on that question.
Brian, we have a question from Hannah in the chat, and I suspect the answer to this is more straightforward than a lot of the things we try to measure, but she's wondering about indoor wood burning. So, a wood burning fireplace, and they're wanting to monitor the pollutants from that.
Yeah.
And she's wondering what we would recommend for a purpose like that.
Wow, if I had a wood burning stove, I would absolutely have a air quality monitor in the room where the stove is, because or fireplace is, because burning wood is a major source of PM 2.5, smoke, soot, carbon monoxide, carbon dioxide, and potentially some of these other things like benzene, formaldehyde, nitrogen dioxide. I mean, whenever you burn anything, you're creating some really nasty stuff. So I think the problem with wood burning is that it pollutes inside your home, and you have to have a really good modern wood burning stove that's very rigorously produced to avoid leakage of that stuff into your home. It's almost impossible. Every time you open the thing to put more fuel in, you're basically inviting all that stuff to enter your room. So I'm not a fan of wood burning for any reason. I understand, though, that there are places, particularly in our rural communities, where access to wood is cheap and available, energy costs are high. Maybe you've got people who are operating at low incomes, so it's a ready resource for home heating. I get that, I acknowledge that, and I see why that's maybe important in those communities. I'd say in urban settings, there's almost zero reason to have a wood burning stove. The most, I think people kind of like it. There's a homey feeling to it. Get over that. It's toxic. It's nasty. There's nothing homey about a fire. It's basically killing you slowly. And this idea of wood fire pits in our communities, and we kind of like to sit around them and talk and drink find something else to sit around, because that thing is just polluting your neighborhood. I wish there was something else that's equally entertaining as a flame that we could all sit around and feel the primordial like attraction to that thing, but it's just bad. And so there's almost no reason to burn anything. I'd say the one exception might be, I can see how when the power goes out, you might, if you have got a wood burning stove or a wood pellet stove or something like that, really handy, because, for a little while you can keep your house warm. But as a main source of heating or entertainment, just avoid it. Grow to hate it, grow to like associate the smell of wood burning with cancer, heart disease, lung disease, and a planet that's, in dire straits. If you can make that association, then every time you come across that, you'll start to get a revulsive feeling rather than attraction, and which is good.
Yeah, I gotta say,
if I went too hard on that, let me know, but I feel pretty strongly about that.
No, it's well said. I'm a reformed, wood burner outdoors with friends, and just the pollution that you put out in your neighborhood is just
Can I just say one
excessive.
more thing about this wood burning thing? Because unfortunately, largely for political reasons, wood burning is considered to be climate neutral. It's absolutely not carbon neutral. Because when you burn anything, it just immediately creates carbon emissions. If you let that log sit on the ground, over decades, it will slowly release carbon and methane into the air. A lot of it will go into the ground and create really healthy soil. There's lots of good reasons to let logs lie on the ground. Almost burning them, it's the worst possible thing we could do. And the fact that it's considered carbon neutral blows me away, because, again, it's political, because there are a lot of countries that have, economies that rely on that, but it's not good for our carbon situation either.
That instant carbon emissions from wood, right? Rather than the delayed decay of carbon. Well, hey, question for you. So maybe just digging into the Purple Air app a little bit. Somebody's asking about, is that map, available to everyone that you showed, that screenshot? Can folks go on and see with Purple Air? Okay.
Absolutely. So you can Google Purple Air, and so on a PC or on a computer, you can go to their website. You can do that on your phone also. There's also an app called PAKU, PAKU, and we'll send links on all this stuff out in our follow-up. But that is an app you can put on your phone that basically is reporting Purple Air data.
Okay, great. And what about we were talking a little bit ahead of the webinar about this. How do you set it up if I understand right, Purple Air has this like crowdsourced data of the air quality that can be, go to your monitor, but you can also have your own individual sensor. Tell us how you do it indoors and outdoors. What's your setup?
Yeah, so with the IQ Air monitor, when you purchase that and you go through the setup, of course, it's going to measure anything in the indoor measurement is happening right there with the device. The outdoor sensor, the outdoor part of it, you basically will go to a menu and choose a device for it to kind of display. And so in some cases, like in our case, we have a Purple Air monitor on our house. So we can get the device to see the Purple Air monitor and report our local air quality from our own Purple Air device. But if you don't have that, what it will do will just give you a menu of like local sources that you can choose from. And, depending where you live, that might be down the street. It might be, several miles away. It really depends on the kind of density of the monitors, outside monitors in your area. But you're going to find one that's close enough to give you really good information about what's going on locally. That's the only one that I know of of the ones that I showed, that's the only one that has that feature, which surprises me because it's so useful. Like if you like to run, for example, my wife and I, grew up running, and there's some days where you just look at that monitor and go, nope, not going to run today because the air quality is just too bad. It's not worth it. You're kind of doing more harm than good. So I just think that that's really helpful information personally, but yeah. Also, we use it also, another thing, we like to sleep with our windows open at night, hear the birds, whatever, because we're in a neighborhood where that's possible. And, if it's cold at night, you get that cold air in, which helps sleeping, blah, blah. But if it's bad air, then you don't do that. So you close the window, put your air filter in your bedroom. So I think that's really helpful.
Wonderful. Thanks, Brian. We have a great question from Caroline about pairing home air quality monitoring or something like Purple Air, whatever it might be, with advocacy or using it as a tool for advocacy. So,
Yeah.
wondering if you could talk a little bit about, ideas you might have or things other organizations. I know during one of our webinars, Dr. Nordgaard talked a little bit about a lending library.
Yeah. I love that idea. So thank you for bringing that up. I mean, okay, at a basic level, advocacy starts with awareness, doesn't it? I mean, so, advocacy, the idea is that you're getting, a group of people, and hopefully a large group of people to push again on some issue. And it starts with awareness, that those people have to be aware that it's an issue. So one of the things I love about these outdoor monitors like Purple Air is suddenly it's really easy for all of us to see how bad the air pollution problem is. And therefore, the next thing you start thinking about is, well, wow, how would we change that? If you think back to the climate movement, that it kind of, a lot of it started in, and even the EPA, the existence of the EPA started by just this awareness in our cities that air pollution was getting so bad. And this was visible air pollution. So LA is the poster child for this, because of pollution was so bad in LA, this beautiful city where, by the ocean, you can't even see the ocean because the smog was so bad. And that really prompted all this stuff, about cleaning up our air, blah, blah, blah. So that was stuff you could see. We still have that problem, of course, but a lot of the things we're talking about, as I mentioned, are things you can't see, which is why this monitoring is so important. So yes, it starts with awareness. These monitors are excellent for that. How you take that information from awareness to action is a really good question that I haven't contemplated a lot, but I love it as an idea. I love the idea of the lending library to help, maybe convince people who are skeptical about this, about what's really going on in their homes. And I love the idea of being able to basically use this information as a tool to convince politicians and other people that we need to do something, because we do. So I wish I had a better answer for you, but I love the notion. And if you come up with a good model for that for other communities, please share.
Yeah, let us know. Cool. I've got two good questions I'm seeing here. One's pretty quick. The first one, can you just, if you're talking about that IQ Air, can you just get one of those and move it from room to room pretty easily, or do they need to be fixed in a place?
You could. In fact, during some of you who live in the Oregon area will remember a few years ago, we had some really, well, here in Portland, we had some unbelievably bad air. It was in the 400s here in Portland, outdoors. So of course, in that situation, you need to close all your windows, turn on every filter you've got. I was shocked to find that when the air was that bad outside, even running all our filters inside, the air was still bad inside my home. I was trying to figure out why that was. Well, it's because your home likely has leaks from outside. And so if you turn on something like a hood for your stove or a bathroom vent, you're actually sucking air in somewhere else. And I found, and so back to your question, I took my little IQ Air monitor and I was walking, because it has a battery in it, so it'll run for a while on battery. And I was walking around from room to room and holding it up to what I found crazy. It was some of our light fixtures, the can lights in our kitchen. had basically, you know, in between the roof rafters or floor joists for the room above, there was an airway that was connected to the outside, and I was getting all this stuff coming in from there. So yes, the short answer is you can move it from room to room. Some of them you're gonna have to unplug and replug in, and it's gonna have to recalibrate and set up all that kind of stuff. So it's kind of a pain, but yes, you can do that. And I would start there maybe, but you know, you don't want to buy 5 of these things. They're expensive. Just decide how many of them you really need. You might find that you don't really need one in another room because you know what you're getting in your kitchen is pretty representative of your whole house. You might find that. So I think it's good. That's a good practice maybe to get one, move it around, see if there's a big difference from room to room. If not, then just keep one.
Yeah. Okay. All right. Second question is on carbon monoxide, which we haven't talked about a lot. You know, there are these carbon monoxide alarms, but Lisa is wondering that there can be lower level carbon monoxide leaks with gas appliances that are hard to detect. Any thoughts on, you know, how sensitive the carbon monoxide measurements are in the monitors that test for this?
Well, that's a good point. You know, the carbon monoxide detectors that we have in our home that are creating alarms, that, you know, that's a threshold kind of measurement, right? So again, it's like when carbon monoxide reaches some parts per million or whatever in your confined space, that becomes considered close to lethal or starting to get close to that like life-threatening level, it's going to make an alarm. Okay, so whereas a air quality monitor is going to tell you the level of carbon monoxide that's in your home, and so it's going to be detecting and displaying lower levels. You know, and it'll probably, I don't know whether they have threshold alarms in them that, you know, if it's starting to get dangerous, but, you know, so basically it's going to give you a number instead of a beep. So you're going to have to interpret that number and just determine what that means for you. Again, I'm not really sure how useful that information is. If you're feeling drowsy, you might look at your monitor and see if you've got relatively high carbon monoxide in your home. But on the other hand, if you don't have a wood stove, a gas fireplace in your, or a gas stove in your home, I don't know where that carbon monoxide would be coming from, unless it's coming from your car, you know, and you've got the door to your garage open and you've been running your car. You know what I mean? So it's kind of like, it's not going to just appear carbon monoxide. It comes from combustion.
Yeah, carbon monoxide detecting is, of course, so important, and I think it's low-hanging fruit here. Joe and I interviewed someone whose batteries weren't present in their carbon monoxide meter, and just had this slew of health issues for quite a while, and it was pretty scary for her. And
well,
so
that's a good point.
heating can malfunction, venting can malfunction. It's definitely,
or maybe, you know, you've taken the batteries out of that thing because you're tired of it squawking at you in the middle of the night and you forgot to put them back in. So yeah, exactly. It's a good point. I mean, it's a good to have some redundancy on that. Yeah.
Brian, I know we're actually running low on time here, but wanted to ask one question. So these air quality monitors are of varying qualities, and there's more consumer grade ones, more research grade ones that can be really expensive. We also know from our webinar on Monday that there's this whole host of pollutants in natural gas. Many of which are carcinogens. We have benzene, formaldehyde, nitrogen dioxide. Of course, we have carbon monoxide. If you were to advise folks to just really more hyper focus on one quality in a sensor, like that could be a proxy for the others. So maybe a sensor is able to detect benzene or nitrogen dioxide. What would be that one that we'd want to really focus on?
Yeah, that's a good question. I would say there may be 2 candidates. One is nitrogen dioxide, because basically again, that's a byproduct of combustion. Typically speaking, these other volatile organic compounds that you're talking about, benzene, formaldehyde, et cetera, also byproduct of combustion. So most likely if NO2 is present, then there's going to be some of these other things present. So I think it's a good proxy. It's also one of the 5 area criteria pollutants that EPA measures. So EPA measures PM2.5. See if I can remember these. PM2.5, ozone, nitrogen dioxide. What are the other ones? Sulfur dioxide, and there's one other one. I'm missing it at the moment. But so it's one of the kind of known criteria pollutants. And so therefore my guess is that, I would, if I had my wish, I would say, let's get nitrogen dioxide sensors to be as good, accurate, cheap, and prevalent as PM2.5. That would probably be a really helpful thing, because it's probably one of the best proxies. The other one that could be a proxy is because some of these monitors have VOCs, total volatile organic compounds typically. And so that's a combination of all sources of volatile organic compounds. And all these things we're talking about, nitrogen dioxide, benzene, formaldehyde, are volatile organic compounds. So potentially, that's like a lumping them all together. The other source of VOCs is things like solvents. If you've got any kind of like household product that's a cleaning product that you can smell, most likely that's got a volatile organic compound in it. So I think it's best to avoid that stuff if you can. I mean, get the unscented stuff, because it doesn't going to have those volatile compounds in it in general. But if I had to pick one, I would say nitrogen dioxide.
Great. Well, thanks so much, Brian. Thanks, everybody, for your fantastic questions. As usual, we'll send the recording, the slides, just as soon as we can. Don't miss our final 2 webinars for Clean Air Week. We have Electrify 101 tomorrow, Thursday, and the Decarb Policy Panel on Friday. So huge thanks, Brian, for being with us for the last 2 days, and we'll see you all tomorrow.
Yeah, thank you.
Thanks, Brian.
Bye-bye.